Hello, my name's Danny, and welcome to the Certified Information System Security Professional course. We'll get started with Domain 1, Security and Risk Management. We will be reviewing the following topics for Domain 1, Information Security Governance and Risk Management, the fundamental security concepts and terms, security governance, legal and regulatory issues, professional ethics, information security frameworks, security policies, standards, procedures, and guidelines, risk management identification, assessment, mitigation, and monitoring. Today, we'll be discussing one of the fundamental principles of information security, confidentiality, and it's part of the CIA triad. Now, I'm not talking about the CIA agency, however, I am referring to the C in CIA as confidentiality. The concept of confidentiality involves limiting the dissemination of information to only those who are intended to receive it. It is important to protect data at all stages, whether it is at rest, in the process of being accessed, or used, or in motion between different systems or networks. There are various requirements for maintaining confidentiality in information systems, some of which are listed here. Personal identifiable information, PII, and personal health information, PHI, should be safeguarded against unauthorized disclosure by using approved encryption algorithms. Sensitive fields, such as passwords, should be masked to prevent them from being viewed by unauthorized users. Passwords that are stored at rest must not be saved in clear text, as this makes them vulnerable to theft or hacking. When transmitting sensitive information, Transport Layer Security, TLS, should be used to prevent interception and unauthorized access. Unsecured transmission methods, such as the file transfer protocol, should not be allowed to minimize the risk of data breaches. Log files must not contain sensitive information that could be used to compromise security. These examples illustrate the importance of confidentiality in protecting sensitive information from unauthorized access or disclosure, and the measures that can be taken to ensure it is always maintained. Integrity is a critical aspect of information security that focuses on ensuring the trustworthiness and reliability of data and systems. Let's go over a few more examples of integrity. Unauthorized code injection can allow attackers to modify the database, making input validation a critical mitigation technique to prevent such attacks. Data integrity involves ensuring that data is both accurate and reliable, free from errors, omissions, or unauthorized modifications. The cyclic redundancy check, CRCs, checksum message digests, hashes, and message authentication codes, MACs, are cryptographic functions used to protect data integrity and detect any changes or modifications to data. Internal and external consistencies ensure that data remains coherent and consistent within a system and between different systems or entities. To ensure data integrity, input validation should be implemented across all forms to prevent the entry of data control language and enforce appropriate field size and data types. To ensure software integrity, published software should include a message digest that allows users to verify the accuracy and completeness of software. To maintain data integrity, subjects should be permitted to modify data when explicitly authorized to do so. In the realm of information security, ensuring that data is readily available is just as important as ensuring its confidentiality and integrity. This is where the concept of availability comes into play. Essentially, availability pertains to the ability of authorized individuals to access data whenever it is needed. Regarding availability, various metrics are used to measure and ensure the availability of data and systems. Some of these metrics include the maximum tolerable downtime, recovery time objective, recovery point objective, SLAs, mean time between failure, and mean time to repair. When it comes to information security, availability refers to ensuring that information and services are available to authorized users when they need them. Here are some examples of availability requirements that may be specified. Software must meet an availability requirement of 99.999% as specified in the Service Level Agreement (SLA). Software should be able to handle access from users simultaneously. Software must provide load balancing to ensure availability. If a mission-critical function of software goes down, it must be restored to normal operations within 30 minutes to minimize downtime and ensure availability. Identity and Access Management, IAM, is a crucial aspect of security that involves controlling access to resources based on the identity of users. It comprises of 5 subcomponents, including identification, establishing a unique identity for each user, which can be done through username, emails, or other unique identifiers. Example, user of an online banking application are identified by their account numbers or usernames. Authentication, verification of claimed identity of a user or system, usually by presenting credentials such as passwords, biometrics, or security tokens. Example, a user enters their password and a one-time verification code to access their email account. Authorization, verification that an authenticated user or system has the required permissions to access a resource or perform an action. Example, a file server allows read access to a particular folder only to users in a certain group. Auditing, recording all actions and events occurring in a system or application, especially those that can compromise security, to ensure compliance and identify potential threats. Example, a security information and event management SIEM system monitors network traffic and log events, such as failed logon attempts. Accountability, the ability to trace any action to its source, which can aid in investigation, forensics analysis, and compliance. Example, a system administrator can trace a change in a database record to a user who made the change, including the time and date of the action. Different types of plans are used to achieve different objectives. Some types of plans include strategic plans, plans to cover a longer time frame, typically 5 years or more. Tactical plans, plans that cover a mid to short time frame, typically 6 months to 1 year. Operational plans, plans that cover the shortest time frame, typically days to weeks. Examples of some types of plans include strategic plan, a company's long-term growth plan for the next 10 years. Tactical plan, a marketing campaign plan for the next 6 months. An operational plan, a production plan for the next week. Protection mechanisms are important in ensuring the security and confidentiality of data and systems. These are various methods and techniques employed to safeguard data and systems against potential threats and vulnerabilities. One of these is the use of protection mechanisms such as layering, abstraction, data hiding, and encryption. I'll go over these in more detail. First, layering. This involves implementing multiple layers of defense to provide a comprehensive security solution. Examples include using firewalls, intrusion detection systems, and antivirus software. Second, abstraction. This is used for classifying data or assigning roles. For example, an organization may classify data as confidential, restricted, or public, and then define access controls based on those classifications. Next, data hiding. This involves hiding sensitive information or functionality to prevent unauthorized access. Examples include password-protected documents and hidden files. And last, encryption. This is the process of converting information into an unreadable format to prevent unauthorized access. Examples include encrypting sensitive files and emails. Data classification is an important process that helps organizations to classify and organize data according to its sensitivity, importance, and confidentiality. Different sectors have their own classification types, and this helps them to implement appropriate security controls to protect the data. The government classification types are as followed. Top secret, information that can cause grave damage to national security. Secret, information that can cause harm to national security. Confidential, information that can cause damage to national security. Unclassified, information that is not sensitive. In the private sector, classification types include confidential, this is financial information or trade secrets. Private, personal identifiable information of employees or customers. Sensitive, medical records or legal documents. Public, information that is freely available to the public. It's important to properly classify data to ensure it's protected according to its level of sensitivity and to prevent unauthorized access or disclosure. Security roles. This is a list of roles and responsibilities involved in ensuring security within an organization. The senior management is ultimately responsible for the security of the organization. The security professional is part of the information security team and is responsible for implementing and maintaining security measures. The data owner is responsible for classifying the data according to its level of sensitivity. The data custodian is responsible for performing day-to-day activities such as performing backups and ensuring the security of the data. The user is the end user of the system and is responsible for following security protocols. The auditor is responsible for reviewing the security controls in place to ensure they are effective. In addition to roles and responsibilities, control frameworks are also important in ensuring security. These frameworks provide a set of guidelines and best practices to help organizations establish and maintain effective security controls. Examples of control frameworks include ISO, IEC 27001, NIST, Cybersecurity Framework, and PCI DSS.